Hi guys, hope all of us are doing great. My name is Ernest and I'd like to welcome us to my channel of Ernest Sciences and Mathematics TV channel. I'd like to request our members to kindly subscribe to our channel and engage us in the comment section so that we can have various feedbacks on the various uploads that we have done and assist one another in improving this specific discussion. So in this case today we're going to look at one of the techniques of integration, and in our previous 3 to 4 videos we have talked about the various rules which we have of course been using in trying to perform this specific aspect of the concept of integration. Now in this case we are going to use the example that I've provided on the board, and it's going to assist us of course try to tackle a few areas that we have mentioned, or rather that we need to know in order to perform these specific steps for the concept of substitution of integral expressions like the one that I've given on the board. Now I'm going to remind us of a few rules which of course we may come across in one of the steps that we're going to use in trying to solve our specific integral for today, and that is going to be of course of very much importance for us to note. So we had mentioned a few rules insofar as integration is concerned, and of course we are going to find that in some areas we're going to use a combination of 1 or 2 rules in order to solve our problems. And I'd like us to give a feedback on the comment section in any case if you have another strategy that we're going to use to solve this. Of course we can have a discussion and try to find out what are some of the inputs that we can be able to put in order to improve our skills on the same. So basically we had mentioned about the concept of constant integrals, and we had given us that suppose we have an integral that we have been given for the integral of k dx. This is going to take a form of kx plus c, where we say that c is an arbitrary constant which is independent of this specific variable for x, and therefore that is going to form what we call the symbol power rule for integration. And then we said we had what we call the constant multiple rules for integration, whereby we say that suppose we have an integral of k fx dx. This is going to be represented as k, the integral of fx dx as such. So in an essence, this particular constant is going to be taken out of the summation sign for integration and be given as that. And then we talked about the symbol power rule for integration, whereby we say that if we are given the integral of x to power n dx, this is going to be given as of course x to power n plus 1 over n plus 1, which implies that we're going to raise this specific exponent by trying to add a unit and then using that one as a reciprocal, or rather as a denominator for this specific expression, and then we're going to add this constant c. So in this particular case, we're going to see that for us to find the values, we're going to have this condition whereby n is not equivalent to -1, of course, for us to find this specific integral in that particular case. So I also mentioned about the concept of exponential functions, or the integral of exponential functions, which are going to be given as the integral of ex dx, and then this is going to be ex plus c that are going to be given as such. So lastly, I talked about the concept of logarithmic functions, whereby we had the integral of the inverse of x dx. This is going to be given as the natural log of x absolute value plus c, given as such. So therefore, these are some of the few rules that we're going to abide by in trying to solve our problem that I've given in the board insofar as substitution is concerned. So there are various ways in which you can be able to combine the rules that I've mentioned, but in our case for these specific ones, then therefore we can see that it consists of an aspect of a particularly a symbol, of course, of what we have referred to as the constant integral, and then we have what we call the logarithmic function, which is appearing in terms of of course x plus 1 in this particular case. But as we go by, we're going to mention the various parts that we're going to come across. So if I may try to look at this specific case, whenever we are trying to employ the concept of substitution, of course, is basically implies that we're bringing in another variable that basically is going to have a relationship with this specific section of the integrand, especially for the denominator that I've given us x plus 1, given in this specific case. So therefore, we are going to use the letter u, whereby we are going to regard u as a function of the x, usually which is going to be part of the integrand that I've given in this particular case. So this is the first set of rules that we're going to abide by whenever we're trying to do substitution, whereby we let u be a function of x, which is usually going to be part of the integrand, be a function of x, where u is going to be part of an integrand. So this is the first procedure. We let u be a function of x, which is going to be part of the integrand. And then we're going to solve for x. So we're going to solve for x in terms of what we refer to as u and du. So we're going to solve for x and dx in terms of u du. So basically that is going to find a derivative of this specific function. And then lastly, we're going to, in these substitution stages, the last one and the third one, we're going to convert the entire integrand function to u and try to, of course, fit into one or more of the basic integration formula that I've mentioned. And then at the last stage that we're going to rewrite this integral as a function of the original variable that was basically x. So therefore, if we try to look at this using those specific rules that I've mentioned, we're going to say let u be x plus 1. So we're going to have the equation x, or rather u is equals x plus 1. And from this we can as well have the derived form of this, whereby we're going to have x being represented as u minus 1. So therefore, in finding a derivative, as we had said from the first condition, whereby we say that let u be a function of x, usually part of the integrand, then we're going to see that du dx is going to be equivalent, a derivative of this is going to be equivalent to 1, whereby we're going to, of course, have this x minus 1, and therefore which is going to be 0, and therefore n number raised to power 0 is going to be equivalent to 1, implying that du is equals to dx. And therefore, whenever we're going to do this specific substitution, for our integral, we're going to have the integral of x. We have found the value of x from this specific relationship to be u minus 1. So therefore, for our numerator, we're going to have u minus 1 all over. The value for x plus 1, as we said, is u. So this is a square of u that is going to form our denominator. And dx is equivalent to du from this specific case. So we have written this specific integral in terms of u using this specific formula. So in that case, if we try to find it being given as such, in some cases we're going to have to of course write this specific aspect of u minus 1 over u, the square of u, in its terms of partial fractions. Therefore, I can be able to represent this one as an integral of u over u squared minus 1 over u squared given as such. So therefore, this just split it into a common denominator which has been given as such, and this is going to be given as du. So if I try to split this one further, I'm going to have the integral of, this can be simplified as 1 over u, and then minus the integral over, this is going to be 1 over the square of u du. So the first one is going to be the integral of 1 over u du minus the integral of 1 over u squared du. So from what we had given us, this specifically, we had given, when we were listing the rules, we talked about the logarithmic function. So the first part of this integral is going to form a logarithmic function that is going to be the natural log of course, u. And then we are going to have this one minus the second part, which is going to be written as, so in this case we can have this one be written as the integral over u negative 2 du given as such. So this one we're going to use the symbol power rule in trying to of course solve the second one, whereby we are going to have it as the natural log of u minus, this is going to be u minus 2 plus 1 over minus 2 plus 1, and then plus c which of course we said is an independent part of this specific variable for u or x, as we had said in our first case. So in trying to look at this, then therefore it's going to be the natural log of u, and then we're going to have minus. So this is going to be u minus, this is going to be minus 1 all over, and this is going to be minus 1. So therefore, I'm going to take out this minus sign, and this is going to represent a positive in this particular case, and then I'm going to remain with u minus 1 plus c. So the u minus 1, I can be able to write it as a fraction, which is going to be 1 over u plus c. So the last stage we said that we were going to replace this specific u with what we had started with in our first case for this specific case for the integral. Therefore, in restoring our fraction for the substitution of u, then therefore it's going to be the natural log of what is referred to as u. So we had said u is equivalent to x plus 1, and then we're going to have this one given as plus 1 over x plus 1, and then plus c given as such. So you can give a variation of this specific answer in any case if you find it appropriate in our section, comment section, so that we can be able to have various ways in which we can be able to have a look at this specific example. So in any case, you have an input, put it in the comment section so that we can be able to assist ourselves in trying to look at the different strategies of finding this particular answer for the question under our discussion. So that is it for now, guys. Catch us in our next video as we're going to look at another strategy of trying to find integration of various functions that we're going to come across on this broader topic of integration. So that is it for now, guys. Bye. God bless.